right, so we'll move on to example 4, and this is more typical of what we will use the um, critical number idea for. So on problem 4, it's simply asking us to find any critical numbers of the function. So I want us to go back to realizing what that means. If we're asked to find critical numbers, then that means that we need to look for places where either f prime of x is equal to 0 or that f prime of x is undefined. So if we find any x values for which that is the case, then we've got a critical number. And from there, we could find extreme values, the maximums or the minimums. So we'll do the derivative f prime of x. Now it's a quotient, so we'll need to use the quotient rule. So Hody Hi, that'd be x squared plus 1 times the derivative of 4x, which is 4, minus Heidi Ho. So 4x times the derivative of x squared plus 1, which would be 2x. And then your denominator, x squared plus 1 quantity squared. All right, now, rarely will I have you do much of anything to the denominator, but the numerator, you really do need to simplify it as much as you can. So distributing the 4, you can have 4x squared plus 4 minus, and then 4x times 2x would give us 8x to the second. And then we can combine like terms, leaving your denominator alone. And so f prime of x could equal then, or would equal negative 4x squared plus 4, and then our denominator over x squared plus 1 quantity squared. All right, so to find your critical numbers, so there we've got our derivative. So to find the critical numbers, we'll first of all look to see where does f prime equal 0. Well, all right, f prime is going to equal 0 since this is a fraction where our numerator is equal to 0. So we can set the numerator equal to 0, and you have different ways that you could do this. One way would be to subtract the 4 and divide by negative 4 to get x squared equals 1, and then do the square root. Remember that when you square root, you get two answers, so positive and negative 1. So there we have found two critical numbers, x equals 1 and x equals negative 1. But I don't want you to forget that critical numbers also occur where the derivative is undefined. And so we do need to take a look to see, is there anywhere that f prime is undefined? So we'll take a look at, in this case, since we have a denominator, where is that denominator equal to 0? So our denominator is x squared plus 1 squared. We'll look at it. Well, we can do the square root of both sides and just get that down to x squared plus 1 equaling 0. Subtracting 1, we get x squared equals negative 1, which in the real number system cannot happen. So from that perspective, we do not have any additional critical numbers. So our only critical numbers came from the fact that our derivative was equal to 0. And so we have x equals 1 and x equals negative 1 as the answer to what we were trying to find.